Welcome to Are You Ready for the Software-Defined Data Center? My name is Patrick Strick, and I am the product manager for storage and VMware integrations at ScienceLogic. ScienceLogic is a company that makes a monitoring software product. We can monitor things in basically any of your infrastructure. If it has an Ethernet port or Ethernet connectivity, we can talk to it. But really, we focus on the infrastructure in your data center and in the cloud. And we're going to talk a little bit about our product, but we're also going to talk about what is software-defined data center and some of the challenges that you might find or you're likely to find as you move towards that type of architecture, if you see that in your future, and I suspect that you will see it at some point in the future. One of the reasons why I suspect at some point you'll see it is, according to Gartner, they expect that 75% of all data center workloads worldwide will be running on a software-defined data center by 2020. That's quite a bit, and maybe that's optimistic. I don't know. 2020 is not too far away now. But it is a good data point just to keep in mind that things are moving that direction. And maybe your whole environment isn't running SDDC, but I would be willing to suspect that at least some parts are. And it's going to be good to be ready for that now and think about the challenges that that's going to bring. Brings benefits to the business, right? The reason that it's going to be 75% is because businesses see value in it, not because it's an interesting technology. But there are challenges, and it's going to be difficult in some places to get there. So why do businesses care? Mainly because it allows them to deliver their applications quicker. Right? So instead of the traditional way of somebody wanting a new application, they submit a change request, the deployment team or multiple teams go and set up the different pieces, both hardware and software that are required for that. With a truly software-defined data center, you could have that customer or that end user would have a portal. They could click, provision the application, and basically orchestration automation handles the majority of it. But that's after the fact, right? Everything has to get built and maintained and deployed to make that a reality. And that's where some of the challenges for you will come in, and that's what we want to talk about. Some of the reasons that it does make things quicker, though, is that SDDC can help remove or does remove the hardware dependencies, right? So one aspect of SDDC is that it separates the functions of the infrastructure from the hardware itself. And another aspect is that it exposes, either through APIs or other mechanisms, a way for those infrastructure components to be managed by an outside entity, like an orchestration engine or automation tool. So what is SDDC? One definition, Forrester, they say that it is an abstracted and pooled set of shared resources, but the secret sauce is in the automation that slices up and allocates those shared resources on demand without manual tinkering. That's a long way of saying it, but I think it really does get to the essence. I would say it a little bit differently in that I would say SDDC is the combination of the software-defined components, compute, storage, and network, in addition to an orchestration and automation layer that brings them together and enables them to provide the value to your business that the business is looking for. You need to have all of these pieces working together in harmony. But because you have all these pieces, it's probably not just as easy as saying you choose one vendor and there it goes. I mean, there may be now, there probably will be in the future, a single vendor that can provide soup to nuts full SDDC. But in most people's cases, it's probably going to be a combination of multiple vendors, right? And you're having to deal with multiple vendors, and each of those tools have their own resource allocation tools. So I'm going to go through each of the pieces of that SDDC just to, I'm not going to spend all day on these, but just to give an idea of what the software-defined aspects of them are. So compute is easy. This is VMworld. I would say that VMware is the definition of software-defined compute. It's now getting broader than that, right? And one of the things I wanted to highlight here is that there's not just hypervisors like VMware, there's also containers. And they don't have to live doesn't have to be an either or proposition. You can have containers running on a hypervisor, but they do have fundamental differences in how they operate. The main thing, and this is overly simplistic, again, I'm not diving deep into these, but the main difference is that hypervisors, the OS for each software-defined entity, each one has its own OS. In a container, they share an OS. They just have separation at the library and application layer. So it's just a little bit of a different philosophy between the two. Some examples, and these are all things that, in all of these examples, they're things that Science Logic can provide insight and visibility into in your environment. So obviously VMware, Hyper-V, Citrix, and Server KVM, and Docker. But even if you have a traditional environment, not just these, so if you have regular Windows or regular Linux, we provide visibility into that as well. On the network side, this slide I did a little bit differently. Or sorry, on the storage side. You've got your traditional storage where, this is very easy. You've got the traditional is you have hardware, it's dedicated to the storage, that there's a RAID layer in between, whether that's a physical thing or a software. And then software provides the data services that take the data from that RAID layer, take the pooled storage, and provide that out as something that clients and hosts can use. The only difference on the software-defined, main difference, is the separation between the data services and the hardware, right? They're abstracted from each other so that the data services can run on anything. But another thing to keep in mind, and this applies to all three of these, is that they have to have some form of be able to be programmed so that they can work with those orchestration automation layers. Examples for these are all things, again, that Science Logic works with on the traditional side and software-defined side. So the major vendors, NetApp, Dell EMC, HP, Hitachi, but also through a partnership with SNIA and their storage management initiative, really any storage system that supports the SMIS protocol, we can work with, and also going forward, there's a replacement for SMIS. I don't know if don't want to spend a lot of time, this isn't a storage conference, but there's a replacement for SMIS called Swordfish that SNIA is also developing, and we're working with them on that. So Swordfish is REST-based. It's actually a really good protocol. So anybody here that's a storage vendor that's working on an API, I encourage you to look at Swordfish. On the software-defined side, that could be anything from your on-premise things like vSAN, Nutanix, but also I consider cloud storage as software-defined as well. I mean, it's obviously the epitome of software-defined storage. And network is a little bit different. And the reason is that the term SDN was really defined prior to the SD everything else definitions. So I'm actually going to start with the other one, which is network function virtualization, which correlates more closely to the previous ones I defined, right? So really, NFV is just a separation of the network functionality, the network services, from the hardware. SDN, as it's been historically defined, doesn't necessarily consider that separation. It's more separation of the control plane from the data plane. The data plane is the part that carries the network traffic, the user traffic, and the control plane is the part that makes the decisions of how that traffic flows. And in an ideal world, that control plane would be accessible through an API so that the orchestration automation tools can talk to it and route things appropriately. Cisco ACI is a prime example of the traditional definition of SDN, or the definition of SDN, where it runs on the same on Cisco hardware, right? It doesn't have the separation of the hardware and the network functions, but it does have a separation of data plane and control plane. Where NSX obviously has a separation because it's just completely a virtual switch. But it also has that data plane, control plane separation as well. And in all these cases, Science Logic can provide that visibility into these components and also the relationships between these components and the rest of the environment. So all of the other components that we talked about as well. And then that overlay on top, the orchestration. And this is the area that's in the greatest, I don't know, change. It's still early, right? There's still companies are figuring out what an orchestration tool should look like and how it should work, and making it, work really well with the underlying components and making it work easy. This is still the part that's in change, but it's also the part that's essential to having a full SDDC environment. So as far as we're concerned, you can pick whichever orchestration tool you want. We could work with any of them. And I'm going to give a couple examples of workflows of how your orchestration tool could work with Science Logic. So on the one hand, you could have, say, a VMware vSAN that some VMs are running off of. Say there's a hardware issue at the vSAN layer. That triggers rolls up to a problem with vSAN, and then a problem with the VM, makes the VM slow or something. Well, Science Logic is looking at all those components, and so we'll get alerts from vCenter, both for the vSAN and the VM. And because we know the relationships between those two components, we'll correlate those events in our event manager. And then you could take that correlated event and use what we call a runbook automation, which is basically our built-in scripting and automation tool. It's not at the level of this orchestration automation, right? This is kind of a more one-use kind of scripting tool, but it's built into the product. And you could take that event and send it to your automation, your orchestration tool, to have it do some kind of a remediation, or at least something to alleviate the pain associated with that problem until the underlying issue could be alleviated. From the opposite direction, we expose all the data in our product through APIs. So anything that we collect across your entire environment is available to the orchestration engine. So if you have a customer who wants to provision a tool or provision a new app, they go through the portal, talk to the orchestration tool. The orchestration tool can then talk to us through our API, find out, say, which data stores have the most capacity, which host clusters have the most CPU available, and use that information to provision intelligently, right? To bring that information together across the environment. But like I said at the beginning, getting to SDDC is hard. There's a lot of steps to it, and the first couple, so this is from, these steps are from the 451 group. I think they make sense. The first couple standardize. You want to standardize on a infrastructure. You need to consolidate your existing things onto that infrastructure, and then virtualize. So once you get to that virtualized part, you've got the three, SDN, SDS, virtualization, software-defined compute. And that's probably where a lot of people are. So 60% are kind of stuck there, though. And the reason is that the next two, the purple ones, are hard to do. To get automation and orchestration going, one, you have to start collaborating across multiple groups within the organization, not only to figure out what the end solution is going to look like, but also moving things into this new way of doing things. It's also expensive from a time, people, and resources perspective to do it right, and to make sure that the details are in place not only to handle provisioning an app, but also the life cycle of all of these components that are in here. All right, these are eventually going to need to be upgraded. You would want that to be handled through the same orchestration automation, maybe not the same physical tool, but the same design philosophy that you've put in place. So I'm curious, how many people have actually gotten all the way through all the steps and are at a full SDDC? Maybe not for your entire environment, but at least somewhere in your environment. None. Okay, there we go. Maybe somebody didn't raise a hand or I didn't miss it, but still, very few. And that's expected, right? It is hard. And that's the challenge that we're going to be working through over the next couple of years as an industry to get there. But again, as I was starting with, I feel that and Gartner and other other people who are looking at this feel that is the direction things are headed. So we will be there eventually. And hopefully, Science Logic can help you along that way. So even after you get to the full purple level there still might be another challenge. And that is the ripple effect of having all these different software-defined components in there, each with their own resource management. The orchestration automation is handling your new provisioning and your life cycle, but still these other things have pieces in them and they might conflict with each other, right? So even though each of the, your NetApp and your Cisco and your VMware have different resource allocation tools and they're all really good in their own context, they don't necessarily know how to talk to each other. So for an example, VMware DRS is going to allocate your resources or allocate your workloads across the available resources. But if you have NetApp and EMC storage and Cisco switches, maybe you have Docker in the environment, DRS doesn't know about those. It can't see into those and it can't know what they're going to be doing for their own reallocations. And it ends up as a big jumble as they somewhat compete for making the ideal environment as resources shift from here to there. So what we want to do is put all of these in the same visible lake, I guess, right? The same visible area so that you and the tools hopefully can know what's going on and have visibility across the entire environment. So we like to say Science Logic controls the chaos. So we give visibility into all of these, and that allows the tools to make you to have some intelligence, and also for the tools to make smarter, safe, self-healing automations. So Science Logic likes to makes SDDC sing together, right? We try to orchestrate it. We want to be the conductor to provide that visibility across all layers. So no matter where you are in the journey, whether you're completely on the non-software defined side and you have your own standalone storage and network and compute, if you're part way up the ladder, you're at the virtualized part, or if you're all the way, we can provide visibility into those pieces and see what's going on so that you can make those decisions and avoid that ripple effect. And then taking it a step further, not just making the technologies sing together, but extending that out to other IT processes. So, for example, you could automate the creation and enrichment and management of incidents in the environment. You can identify unapproved application configurations or unapproved changes or non-conformance configurations. So I want to give a real example. So we have a customer, Worldwide Tech, who is using our product in addition to these other things you can see here, vCenter, Cisco Cloud Center, and Cisco ACI. And one of the things they're doing is delivering content management to customers over WordPress. So they've put together a workflow based with Cloud Center doing the orchestration and using Science Logic to help facilitate that workflow and also to have visibility into it afterwards. This is the overall infrastructure design, and you can see the components there. It's hard to tell on this screen, but so that is, what is that? I'll say these are the VMs, right? And that's the cluster. But what you can see is the lines go from the VMs to VMware, right? They're obviously part of that, but they're also connected to the ACI tenant and the Cloud Center workflow. Because once each of those components is discovered, the Cloud Center, the ACI, and the vCenter, we see all the children of those components, and we also know what the relationships are between them because we've partnered with each of these companies and we know how they interact with each other. So when you have a VM that's being used by ACI, we can make those relationships between the two. Looking at just the Cloud Center, very similar. So it automatically, as soon as you discover Cloud Center, we discover all of its children and build those relationships. So the example is deploying that WordPress application. The end customer goes through their provisioning portal, clicks provision, Cloud Center does its thing, spins up VMs, deploys the application onto those VMs, and sets up the database tables. And then you have a provisioned application and at the end of that. And because of the connections between it within Science Logic, we have an automatic grouping of all the pieces of that application together. You can see that the 3 virtual machines in here and then all of the other pieces. This is not real clear though, right? So let's look at it a different way. You can see here highlighted with the arrow is the WordPress application that's been auto-discovered after it was created. And it's an ACI tenant in this view here. So we click on it, and you can see the tenant that it belongs to, but you can also see the connections it has to the 3 virtual machines that were provisioned during the spin up from Cloud Center. If we click on that one of those virtual machines, then we see the connections it has, right? So we know the data stores that it's on, the port group that it's using, the physical hosts that it's on, all of that. So we can bring all those pieces together to show what's going on with, I'm gonna go back to this one, what's going on with the overall environment. Now this is just one setup, and obviously, one thing to take away from this is pretty complicated from the setup of the orchestration side, right? But it's still a very simple WordPress application. Needs some VMs, needs database. Just getting to this required, I believe, months of effort, right? It's not the most straightforward to go from 0 to having this. But hopefully we can provide you, as we did with Worldwide Tech, some assistance in the visibility to make that happen. So some takeaways from this session. This is short, right? I realize this is a little short, so we'll have plenty of time for questions. There's a lot of open here. I have plenty of things that I can discuss with you, but I wanted to make sure that everybody has their own needs in this space, and I wanted to make sure that we could address each of your needs kind of as they come up, right? This just covers the general, but the main takeaway is that software-defined data center is inevitable. I mean, whether it's your whole data center or a small window of it, there's going to be some aspects of it. And so it behooves you to be ready for it. And we want to be there to help you. So we can bring that visibility and connectivity into the rest of your orchestration systems and your infrastructure so that you can make the intelligent decisions you and those tools need to. Love to talk to you in booth 318. If you want to talk to one of the product experts there, they'd be glad to set up a one-on-one session. I'm available here. We can talk as much as you would like. So Science Logic wants to help you do IT better. Thank you, and please fill out your surveys. Let us know what you thought. I'd like to, feedback good or bad, I'd love to hear. Thank you very much.